Hello everyone, my name is Carlos Ferreira. I am from Federal University of Minas Gerais and Federal University of Ouro Preto, both in Brazil. Now I am PhD visiting at Smart Data Center located at Polytechnic Torino in Italy. In this talk I will present a work named Unveiling Community Dynamics on Instagram Political Networks. Nowadays, online social networks are an important part of many people's lives. As a consequence, they are a core component for information spreading, marketing, and advertising. Among the various options of online social networks, Instagram has grown in popularity due to the large volume of rich and dynamic multimedia content, providing a powerful platform for influence and social mobilization. So, a complex ecosystem emerged around what we know as influencers. So, in a quick overview of Instagram, here's an example of how an influencer profile is presented in Instagram web version. I chose Cristiano Ronaldo as example, a famous football player, not at random, but because he is the personal account on Instagram with the largest number of followers. To give an idea, there are more than 200 millions of followers. It means that there are more users explicitly interested in his content than the entire Brazilian population, the fifth largest country in the world. So, in general, influencers have a large number of posts, including photos and videos. Also, their posts attract other users that make comments. Here we refer to the users commenting on posts as being commenters. In this context, this direct interaction ecosystem with people at scale has been also explored by politicians. And we have observed very few efforts on how commenters co-interact on posts created by this specific kind of influencers. So here our main goal is to understand how people interact around politics influencers in the Instagram ecosystem, modeling the dynamics of the co-commenters network, a network that emerged from comments in influencers' posts. As shown by this example, where one post receives co-commenters such that a network emerges forested by influencers' posts. In our network, nodes are commenters and ads indicate that two commenters have commented on the same post, where the ad weight represents the number of times they commented that it's interacted on the same post. Then we tackle two research questions. First, which structures emerge from co-commenters network on political profiles? In this question, we are interested to review underlying structure that fundamentally captures users' behavior, named backbone, and also to find groups of commenters who often co-interact, forming communities based on interest in the same posts. In the second research question, we would like to know how do these structures evolve over time. Basically understand the dynamic of communities found in research question 1. In order to answer these questions, our methodology starts with the network model before presented. The main challenge of this network modeling is that it features with high order interactions, becoming a network highly connected. It writes any underlying structure able to reveal the commenter's behavior. So, make it difficult to distinguish structural patterns from sporadic, weak, or incidental interactions, mainly working with millions of interactions as we are modeling here. For instance, two commenters may become co-commenters by chance, if a very popular post attracts lots of attention, or if they are very active, that is, comments in all posts of a given influence. In both cases, as implied here, it is expected they become co-commenters at some point. In light of this, we are interested in salient interactions, those that don't occur by chance, and by design form the network backbone. Also, it should be able to provide a clear image of the network structure. Then, in order to identify the salient interactions and the backbone formed by them, we define a probabilistic network model able to predict the expected ad weight based on the opportunities that two given commenters have to interact, that is, comment on the same post. This model yields one distribution for each ad, and its key assumptions are: first, to consider the probability that user U comments on post P is proportional to the popularity of the post and also the activity left of the U, and that all commenters behave independently. The ad weight follows a Poisson binomial distribution, and it is used to contrast with the weights in the observed network. More detail of this model as well particularities is available in the paper, so I would like to invite you to read it and check them. We consider an ad salient if its observed weight exceeds its 95th percentile in the probabilistic null model. To make it clear, we have here a toy example of a co-comment network with 3 nodes and 2 ads representing the number of co-interactions between 2 commenters. And we have the expected network obtained by our model with ad weights computed according to the 95th percentiles. Comparing individual ads in the observed network with its expected value in the expected network, we can see that the weight of the ad between nodes I and j doesn't exceed the expected one. Then it is not salient for us and therefore removed of the graph. On the other hand, the weight of the ad between nodes I and k exceeds the 95th percentile, as you can see, remaining the backbone. Last, isolated nodes are removed of the graph. The next step then is to identify communities formed by commenters who co-interact in an expected way. Communities here represent potential ideological groups, users engaged in posts of one or more influencers. These influencers can be politicians of the same ideology, of opposite ideology, or something like that. To do it, we use an Unveiling algorithm. It's a traditional algorithm to identify communities in complex networks. Then we use modularity as a criterion to evaluate community quality. From this methodology, we did our analysis aiming to answer our research questions, collecting a large dataset covering 10 weeks during the electoral period of Brazil 2018 national general election and Italy 2019 European election. So as described here, from 80 influencers each scenario, we have several posts, millions of comments carried out by millions of commenters. So we are the first to study how people interact on Instagram about politics on a large dataset in 2 distinct scenarios. Also, we complemented the dataset with non-political influencers, that is, football players, singers, actors, cooking, and so on, for the respective periods in both countries. And despite not having details here, this dataset is even bigger than the politicals one. More details, including the criteria for selection, can be found in the paper. Considering 10 weeks, we define them as being snapshots. Then we create one network model for each one, extract the backbone, and identify communities of commenters on the profiles analyzed here. Here we have some views of our dataset, such as the number of posts per week in both scenarios, and we can see that political influencers post more than non-politicals one, mainly around the election period as highlighted here. In relation to the number of comments that these posts receive, first, although general influencers post less, they receive more comments as present here. After, we can see a greater engagement around the election period, and even more in the week after the election. Starting by the research question 1, what structure emerged from the backbone of the co-commenters network on political discussions? Remember that we are here focused on communities of commenters interacting around similar posts. So we would like to show the structure emerging for the backbone. Here is an example of one snapshot for Brazil political scenario. And comparing the original network and the backbone network, we can see at this table the difference in terms of number of nodes and ads after to apply our model. It's possible to see that many non-salient ads are removed and also isolated nodes. In relation to the communities found using Unveiling algorithm, In both networks, we can notice a large number of much better shaped communities identified after pruning non-salient edges. So we propose a novel, efficient model to extract salient link on Instagram. Also, there are a long discussion about this result in the paper, so I would like to suggest you read it. Here is a breakdown for all scenarios, that is the average of all snapshots for each scenario. We can see that in politics, more nodes remain in the backbone, suggesting higher engagement by commenters. Also, we can see that for general scenario, a large number of communities is found. It is expected given the diversity of topics. Basically, in politics, we have one context, only politics, and for general scenario, we remember that we have cooking, actors, football players, and so on. And in relation to the modularity, that is how strong are these communities, we can see that they are very well structured. We also analyzed how communities are interested on profiles. To do it, we analyzed the activity of communities on a subset of influencers. This analysis considers the snapshot covering the first half of the election period in Brazil for the politics scenario. The subset of influencers picked up is composed of the politicians candidates of the respective election. And just to clarify better this graph, looking first at the y-axis, we have the communities found in the respective snapshot. On the x-axis, the influencers. Thus, each cell here corresponds to the fraction of all comments posted by communities on influencers' posts. So we can see most communities are strongly attracted by Mr. Bolsonaro posts, but they differ in terms of the post topics that they most often comment on. We picked up some examples that are here for community 3 and community 7, where community 3 are more interested in rally events, while community 7 is more interested on posts discussion about racism. I mean, these are posts that receive a majority number of comments for this community in specific. Also, we found communities formed around posts of many candidates promoting debates or discussion different things, and also communities particularly interested in others influencers. Summarizing, we saw that communities are around influencers and also around specific content. Just to exemplify how these communities are placed in the network, we selected 4 communities from the previous analysis and plot them here. Starting by community 3, more focus on Mr. Bolsonaro, then community 7, also focus on Mr. Bolsonaro. We can see that communities formed on the same influencer are close in the network, although they have specific interests. After we plot community 11, more focus on Mr. Ciro Gomes, more distinct from the others, because Ciro Gomes is a left-wing influencer in this case, while Bolsonaro is right-wing, so it is expected some difference between them. And last, community 10, more focus on Mr. Haddad, another influencer or candidate left-wing. So we can see that communities formed on influencers with similar ideology share some overlapping, as we can see for community 10 and community 11, where Ciro Gomes and Mr. Haddad are more closer than Bolsonaro. There are other interesting analyses in this paper focusing on similarity and ideology of communities. Once again, I would like to invite you to read them in the paper. We finally turn our attention to the research question 1, aiming to understand how do this structure evolve over time, more specifically if the communities persist over time as well the communities formed by them. To that end, we computed 2 complementary metrics for each pair of consecutive weeks. The first is persistence. We define persistence from week X to week X plus 1 as the fraction of all commenters in week X who remained in any community in week X plus 1. Here, in our example, we have 2 distinct communities in week X, each one with 3 members. After the next week, all members still remained in the network backbone regardless of which community. Then we have a persistence equal 100%, implying that all commenters remain in the network backbone in these consecutive weeks. Yet, remaining commenters in the backbone may have changed to different communities, such as the commenter L here. To assess the extent of change in community membership over consecutive weeks, we computed normalized mutual information over the communities. This measure is based on channel entropy, and it is explained in more detail in the paper. Its values range from 0 to 1. It is 0 when all commenters change their communities, and it is 1 when all commenters remain in the same communities for these consecutive weeks. This way, this graph shows the persistence for Brazil politics scenario. Our results can be found in the paper, but we also analyzed the 1% and 5% most active commenters, as highlighted here. So we can see a high persistence of commenters, especially around election period, independently of the activity level. And also we can see that most active commenters are more stable in their communities. In relation to the general scenario, also for Brazil, we can see that commenters are more persistent and more stable in their communities than in politics. In conclusion, our model allows to see that behind of co-commenters Instagram network, we have a large number of commenters sharing interests in posts and influencers. These commenters form communities well structured on the network. Also, we saw that the debate promoted by politicians and influencers is more intense compared to the others, generating a higher and incessant interactions on elections. As future work, we intend to investigate coordinated behavior on Instagram and to do a deeper analysis on the content properties that the communities are interested in. Thank you for watching our video. I hope you like it. If you have any question, I would like to receive images with it. Finally, I would like to invite you to access the project web page using the QR code. Bye, and I will see you next time.